Start recording. Okay. All right. Are you able to see these slides, the PowerPoints?
Not yet hocam ama it's coming I think. Because the screen has changed.
Okay. Let me know when you are having this, when you got the screen.
Okay, sir. Yes, we have it.
Yes.
Okay. Okay. The panel data, as you know, it is a little bit more complicated than OLS or ordinary least square. The regression analysis is also here, but we are doing for the panel data. We are doing for some countries, some let's say industries, some different association of the data, which is comprise the similarities and similar variables in different, let's say, destination or section or institution. Panel data is very important because we are able to do more comprehensive or more extended version of our estimations regarding to the, let's say, countries or the industries that we are wishing to estimate, evaluate, and compare their performance, the parameters that we already considered in the model. The group data is, as I said to you, it is dependent which group, what kind of variables you are dealing with, and what kind of estimation you are planning. The main interest group is not the individual units in the group, units in the group, which is in the group, which means that very little information is lost by taking the panel perspective. The use of panel rather than time series data not only increases the total number of observations and their variations, but also reduces the noise coming from the individual time series. Noise is the signal whose samples are sequence of unrelated random variables or random variables with no mean, which is sigma x divided n, as you already exercised in the descriptive statistics. And it is then the limited variance. The question why we are using panel data, it is because best suited where data availability is an issue, particularly for developing countries where short-term or emerging economies, where short-term time spans, space for variables are rampant, mostly or often insufficient for fitting the time series regression. There is heterogeneity, which means the differences among units in the panel, and panel estimation techniques take their heterogeneity into account by allowing for subject-specific variables suited for studying dynamic changes due to repeated cross-sectional observations. The panel data combines cross-sectional and time series data and looks at multiple subjects and how they change over the course of time balanced and unbalanced panel. In microeconomics panel, the individuals are not always interviewed the same number of times, leading to an unbalanced panel. And in an unbalanced panel, the number of time series observation is different across individuals. And in a balanced panel, each individual has the same number of observations. The descriptive panel data is the reason for using in its format. assess the importance of fixed or random effects. We are examining the Hausmann test, which determines if the fixed or random effects should be used for the collinearity or serial correlation, is going to question, and evaluate some panel data models. The panel data are the models that combine cross-section and time series data, as I mentioned to you. In panel data, the same cross-sectional unit, industry, firm, country, and some other is survived over time. So we have data which is pooled over space as well as time. Reasons for using the panel data can take explicit account of individual specific heterogeneity. Individual here means related to the micro units. By combining data in 2 dimensions, panel data gives more data variation, less linearity, and more degrees of freedom. And panel data is better suited than cross-sectional data for studying the dynamics of change. For example, it is well suited to understanding transition behavior, such as companies bankrupt or merging. Panel data to detect and measure effects that cannot be observed in either cross-section or time series. Panel data enables the study of more complex behavior models, for example, the effects of technological changes or economical cycles, such as dynamic cycles that we are starting business and then it goes, improve, develop, and then it is reaching to the top and optimal position, and then it is again in the recessionary period is realized. Panel data can minimize the effect of aggregation bias from aggregating firms into broad groups. The panel data analysis involves using a combination of cross-section n or n's amount of, let's say, country and time series, which is the years, observations for the analysis. And n is the group, firms, countries, industries, individuals, etc. And time is the number of years, as I mentioned. Panel data variant, long panel means large n and large t, time, years, and large countries. And short panel is the large countries or large n and small period. Let's say 10 years. And large means 20, 30 years. Heterogeneous panel, large or small n and large panel, but n is smaller than time. Static panel is only exogenous, variables are regressors, and dynamic panel inclusion of lag-dependent variable as regressor in the series. The heterogeneous dynamic panel data modeling steps can be specified and classified as the specifying the model, describe the statistics or descriptive statistics can be analyzed, the correlation analysis can be done, which is dependent to the performer, whether you are going to use or not, it is up to you. There are some optional performances here, and perform the unit root, which is must. An optimal lag selection co-integration test is also optional, can be done by panel co-integration. Pedroni can be used mostly, and perform Hausmann test, and estimate the model, and the causality also optionally can be used, and the diagnostic is preferred. Let's see the step by step. The model that we are planning today, we are only concentrating to the the ARDL today. I'm going to present you the ARDL. And vector error correction, it can be also, and panel co-integration can be also introduced to you. But first, we are introducing you the ARDL, where the I0 and I1 in same estimation considered. So mixed variables assumed to be considered in this model. And if the variables are at level as stationary, then we are using OLS. And if the variables at stationary get first difference, then we are using the vector error correction, the Johansen approach, which is a little bit more simple. We cannot estimate conventional OLS or ordinary least squares on the variables methods, I mean the OLS methods on the variables if any one of them or all of them are I1, which is in the first difference, because these variables will not behave like constant, which is required in OLS, and as most of them are changing in time, so OLS will mistakenly show high T values and significant results. But in reality, it would be inflated because of common time component. In econometric, it is called spurious results, where S square of the model becomes higher than the Durbin-Matson statistics, which is also important. As you know, the Durbin-Matson statistic is also a very helping hand for determining the correlation, the autocorrelation or serial correlation. As you know, if the Durbin-Watson results is close to 2, means very low autocorrelation. If it is close to 0, means strong positive correlation. And if it is close to 4, means strong negative correlation. So we move to new set of model which can work as I1 variable. The panel IRDL is mixed, as I said to you. We are going to concentrate to the model which is given here. As you are observing, the output is in the equation given as the summation of the delta y1 can be any parameter, plus then the x is going to be represented with the error term also in the model. The estimation of the ARDL, some preconditions is required here. Dependent must be non-stationary in order for the model to behave better results or perform better estimation, because it is must, and none of the variables should be in the I2, which means the second differentiation is also not preferred in most of the tests, and we are not also preferring here also. In normal conditions, we are looking to the ADF, so augmented Digi-Fuller, and then controlling to get whether I0 or I1. And none of the variables should be in I2 in structural base, where this what Andrew test is performed. The optimal lag is also control here. First, we need to check the lag order to see what lag past period, you know, the lag is the former period, must be adapted to the current period, and this should be must be somehow parallelly developed for reaching to the results. We use this AADF test for estimating and evaluating the variables significance, which is the model we are using performed probably the suitable for this test. This is done using the vector autoregressive specification order criterion available in Stata that can be quickly applied, or in eViews you have to do it after var model and check it the lag length criteria. In statistics and econometrics, a distributed lag model is a model for time series that data in which a regression equation is used to predict current values of a dependent variable based on both the current values of explanatory variables and the lagged values of these explanatory variables. Then we come to the second part, the descriptive statistics. As you know, we already introduced you the descriptive statistics where you are doing, which is very important for helping hand, that you are determining the mean, median, mode, standard deviation, skewness. These are the helping hand for estimating and evaluating the parameters and the considered model, which explain the characteristic of each variable in the model, and possibly they relate to each group to engage a comparative statistic. Then you are going to determine whether you are going to employ this or not, this test or not. The correlation analysis, as I said to you, is also important. This shows the regressors that not have perfect or exact linear representation of one another. And the autocorrelation or serial correlation is also considered, although difference to autocorrelation using the usual OLS model, a version of the Darwin-Watson test can be used, as I mentioned to you. That is the usual way, which is expected to be less than 2, is or somehow near to 0, is the reason for positive serial correlation. And to remedy the autocorrelation, we can use the usual methods such as the error correction model. And the dynamic model often used, which basically involves adding a lag-dependent variables. And recently, the use of method for adjusting the standard errors has become popular. The most common method is termed the Newey West adjusted standard error. Then the unit root is performed, the assertion that no variables integrated in the second order for performing the first and second generation, and determining the lag selection, the optimal lag, using the unrestricted model or restricted var. It is dependent to this. And information criteria decide the choice of lag for each unit or group per variable. Then choose the most common lag for each variable to represent the lag for the model. Either you are going to use restricted or unrestricted var model in this direction for the vector error correction. The co-integration test is also performed. The Pedroni, as I mentioned to you, CAO, which is in 1999 and in 2004 performed and introduced, and Westerlund 2007 co-integration test, but on the assumption of the long-run homogeneity, this step can be skipped. Co-integration is ascertained from the statistical significance of the long-run coefficients, essentially co-integration or long-run coefficient present itself as the joint significance of the level of equation. And the Hausmann also, as I said to you, the null hypothesis is if probability value is less than 0.05, is then not preferred. The Hausmann test for the statistical significance of the different estimates obtained by fixed effects and by the random effects under the null hypothesis that the random effects are efficient and consistent and the fixed effect estimates are inefficient. The null hypothesis supposed to be random effect is appropriated, and the alternative supposed to be fixed effect is appropriated. When the probability value is higher than 0.05, it has meant no serial correlation results are not significant, and we cannot reject null, means random effect is appropriated. The test has a Wald test form and is usually reported as chi-square, from which t minus 1 degrees of the freedom is represented in the number of regressors. And if the Wald test is less than critical value, then random effect is then preferred estimator. The number 8 is the estimation of the model. If the test favors the pool mean group estimator, observe the statistical significance of the long-run coefficients and the size of group-specific error adjustment coefficients and the short-run coefficients, and finally interpret the results accordingly. Up to now, if you have any question, please let me know. If not, then I will continue to this presentation. Okay, then the causality test, perform Granger causality test and Wald or weak exogeneity test. These steps can be also optional, and the causality can also using significance of the error correction term for joint causality, long-run coefficient, short-run coefficient, and the error correction term long and short-run coefficients for strong coefficients is supposed. And the diagnostic test should be good not panel, and the results can be compared. And after this introduction, then the basis of the panel ARDL, so-called the fixed effects and the random effects, will be performed. The mean group estimator is supposed to be proposed by the less informative, the average, the data, the estimation of the n-separate regression, examination of the distribution of the estimated coefficients across groups, and produce consistent estimates of the average of the parameters. And the parameters are freely independent across the groups and does not the fact that the certain parameters may be the same across groups is supposed to be for the mean estimator. And the dynamic fixed effects is then the intercept differ across groups, slope coefficients and the error variance are identical and allows the dynamic specification number of lags included to differ across groups. And pool mean group estimator is again Pesaran-Shin in 1999 performed an intermediate estimator between mean group and the dynamic fixed effects, involves both pooling and averaging, allows the intercepts and long run coefficients are the same, and it generates consistent estimates of the mean of short run coefficients by taking the simple average of the individual unit roots. It's supposed to be realized. And the problem here, which direction we have to go, we're gonna determine now by using this presentation. The mean group or the pool mean group estimators, the mean group provides consistent estimate of the mean of the long run coefficients but these will be inefficient if the slope homogeneity hold. And the pool mean group estimators are consistent and efficient under the assumption of the long run slope homogeneity. Homogeneity, as it is in homogeneity, is important to perform if the data set is homogeneous before statistical technique is applied. For homogeneity, all outside processes that could potentially affect the data must remain constant for the complete time period of sample. How to do it? Calculate the median, subtract the median from each value in the data set, count how many times the data make a run above or below the median, which means the persistence of the positive or negative values. And then we're gonna determine mean group or the pool mean group. Then we perform the Hausmann test for the null mean group and the pool mean group estimates are not significant. Different pool mean group more efficient and the alternate is not true, supposed to be. And the decision after this performance, use the pool mean group if the p-value is higher than 0.05. Null hypothesis cannot be rejected. Or use mean group if p-value is lower than 0.05, then null hypothesis will be rejected, whereas the p-value is less than 0.05, isn't it? The mean group and dynamic fixed effects then question which one is going to be determined. Perform again the Hausmann test, the null hypothesis, mean group, and the dynamic fixed effects estimates are not significant. Different dynamic fixed effects more efficient, and the alternative null is not true. The decision here, use the dynamic fixed effects if the probability value is higher than 0.05, and then null hypothesis cannot be rejected. And use mean group if p-value is lower than 0.05, you're gonna reject the null, and this will then means probability value is less than 0.05. Then dynamic fixed effects and pool mean group, the performance of the Hausmann test again is in the agenda. The null hypothesis, the dynamic fixed effects and the pool mean group estimates are not significant. Different pool mean group more efficient. Null and an alternative is then the null is not true. The decision here again, use the pool mean group if p-value is higher than 0.05, then null hypothesis cannot be rejected, and use dynamic fixed effects if the p-value is less than 0.05, which means the probability value is lower than 0.05. The panel data regression models units over several time periods are based on panel data, which are observation on the same cross-sectional or individual. A balanced panel has the same number of time observations for each cross-sectional unit, and panel data have several advantages over purely cross-sectional or purely time series data. These must be include increasing the sample size, study of dynamic changes in the cross-sectional unit of over time, and study of more complicated behavioral models, including study of time invariant variables. Damodar Gujarati, which is very popular econometrics, is in the agenda. If you look up the book, then you will get better, let's say, knowledge and comprehensive information about this topic. And the panel data regression models, the panel model pose several estimation and inference problems such as heteroscedasticity, autocorrelation, and cross-correlation in cross-sectional units at the same point in time. And the fixed effects model and the random effects model, also known as the error components model, are commonly used methods to deal with one or more of these problems. Model, the intercept in the regression model is allowed to differ among individuals to reflect the unique feature of individual units. And this is done by using the dummy variable, providing we take care of the top. And the fixed effect model using dummy variables is known as the least squares dummy variable model, least square dummy variable. And the fixed effect model is appropriate in situations where the individual specific intercept may with one or more regressors, but consumes a lot of degrees of freedom when n, the number of cross-sectional unit, is very large. Within group estimator, an alternative to least square dummy variable is to use the within group estimator. Here we subtract the group mean values of the regressant and regressor, so-called independent, from the individual values and run the regression on the mean correlated variables. Although it is economical in terms of the degree of freedom, the mean corrected variables wipe out the time invariant variables such as gender, race, and such other properties in the model that can be used for estimation. The random effects model assumes the intercept value of an individual unit is the random drawing from a much larger population with a constant mean. The individual intercept is then expressed as a deviation from the constant mean value. REM is, more economical than FIM, so-called fixed effects, and in terms of the number of parameters estimated. And the random effects model is appropriate in situations where the random intercept of each cross-sectional unit is uncorrelated with the regressors. Random effects and fixed effects estimations. The fixed effects model assumes that each group or so-called firm or country has non-stochastic group specific components to Y, including dummy variables, is a way of controlling for unobservable effects on Y. But these unobservable effects may be stochastic, which is randomly. The random effects model attempts to deal with the model as it is given below. Y is equal to A0 plus A1 x IT plus V plus error term. Here, the unobservable components, the V is treated as a component of the random error term. And VI is the element of error which varies between group but not within group. And error term is the element of the error which varies over the group and time. The choosing between fixed effects and the random effects and small n, I have already explained to you in the former slides. There is likely to be little difference, so fixed effects is preferable as it is easier to compute. With large number and small the time, the years, estimates can be differ significantly if the cross-sectional group are random sample of the population, so random effect is preferable. If not, the fixed effect is preferable. And if the error component V is correlated with X, then the random effect is biased or not rational, but fixed effect is not. For large N and small t, and if the assumptions behind random effect hold, then the random effect is more efficient than fixed effects. Fixed effects or random effects. If it is assumed that error and the regressors are uncorrelated, the random effects model may be appropriate. But if they are correlated, then the fixed effect model may be appropriate. In the former case, we also have to estimate the fewer parameters. The Hausmann test can be used to decide between fixed effects model and random effects model. The null hypothesis underlying the Hausmann test is that fixed effects model and the random effects model do not differ substantially. The test statistic has an asymptotic, and if the computed chi-square value exceeds the critical, the chi-square value and the level of significance, we conclude that the random effects model is not appropriate because the random error theorem are probably correlated with one or more regressors. In this case, fixed effects model is preferred to random effects model. This was the presentation for today. It is a little bit faster gone, but as I said to you, this is the theoretical presentation. And I will, after this lesson, upload it to the YouTube again, because this will not stay too much longer until the final probably. Then you may watch and repeat this presentation, because there are crucial and very important points that you have to take into consideration when you are doing these panel presentations and final estimations. Therefore, I advise you to follow up this presentation as much as possible until your final, for being able to get better result. I am not talking about for the students who reach the top. I appreciate for those who studying well and who are getting higher marks. I really very appreciate and become very happy for those who studying and getting good performance in my class. If you have any question or any, let's say, suggestion, I'm waiting you. If not, then I will stop this and finish this class for today. Do you have any question or anything else to ask me? Today you are very silent. Ahmet Dursun,
we
yes.
have to digest it a little because there is lots of information here.
Yes. You want what? More? You
No, I mean,
want
maybe we have to
the
read it
performance of
ourselves
the
and
interview, you mean?
no. This chapter that you have already covered, it's so many
Yeah.
different stuff that you talked about. We have to digest the information first to have the questions, I guess.
Yes, I have understood. Okay. It is really a little bit short and comprehensive. You know, I gave you only the critical points, and you get in and research and understand better maybe, or you perform it as it is given to you, because I have already given you the more panel. You understand, mostly people are not getting this information and start to do panel just as it is in OLS or in other, then this will then create problem, because every performance dependent to the model and test that you are doing, you are performing. Therefore, as I said, you digest it, you read it, you watch it, and try to understand better. I will also upload the PowerPoints, so you can also download and read also there. And this will then probably helpful for you for performing this presentation. I will also present next week one simplest again, and then let you to perform from you. And this will be added to your final. You understand? I am trying to help you because I am observing some students are in need. They need some contribution for getting better results. Of course, not Hussein and Abia. They did very good. I am really appreciating. But we will see. I will, after this, then perform. I will start with Pedroni, probably. Simple one, and then go to a little bit deeper. Okay, then go to ARDL, vector error. We will do some as much as possible. Okay, then if you don't have any question, then we will perform next week EU. Okay, so you can see how we are going to do this panel in EU. If you don't have any question, then I will appreciate it for your attendance or your
Thank you,
joining.
sir.
Thank you,
Okay.
Hocam. Thank you very
Thank you.
much.
Thank you very
Thank
much.
you.
Thank you, sir.
Bye. Bye. Have a nice evening.